This is for lesson book 3-2, interpreting linear equations. And so now that we've kind of practiced graphing linear equations, we want to give it a little bit of meaning. So as we finish this class and then go on to statistics for most of you, we apply these linear equations to real world things. So these equations, which were just graphs and equations, right, become something that represents the world. So here's a problem situation, blood alcohol content. And so here's this kind of intimidating looking equation here that represents the amount of blood alcohol, amount of alcohol in your blood system. And so notice there's multiple variables. And so what variables influence this? You can see the list right here, right? Your weight, the number of drinks you've had, how long you've had since your first drink, and then depending on whether you're a male or female, you have different values, or what we call this constant, this gender constant. And so looking at this equation, it looks complicated, but if you're given a specific situation like these here, where you have this case where you have a male student, 120 pounds, who had 3 drinks, right, you can then see that this complex looking equation, after you substitute these values in, becomes this equation right here. And so that's again what's simplifying. So use your calculator, multiply 2.8 times 3, and then divide that by 120 times 0.68. You should get this. So make sure you do that on your calculator to get this equation. Once you have this equation, then we can determine the blood alcohol content for this individual here. So looking at this equations here, you'll see we substitute 1, 3, and 5, and so you can see the blood alcohol content. And I guess if you're using the 0.8 marker, you could see this person is still legally drunk, versus after 3 hours, his BAC, blood alcohol content, has decreased. And so how much does it change per hour? It drops or decreases 0.015. Right? And I shouldn't put a negative. Decreases 0.015. And that comes from this value here. This number here is what we call the slope. What we learn is this is the slope, and this is what's called the y-intercept of a graph, where the y-intercept is where the line will cross the y-axis. And so you can see after you have your points, you plot the points, you can then start to see this pattern that's formed here. You have a linear equation. Notice you're going to have a line so that we can then see at some point his blood alcohol content would reach 0 after a certain amount of time. And so then using this equation here, you could see like this question, what would it be after 8 hours? Is it reasonable? The answer is no. Well, you plug in 8, you get a negative answer. It's because blood alcohol content can be negative. Once it's 0, it's done. But that's how we would use the equation to make a prediction. What is this BAC at 6 hours? You would substitute that in. So that's what we're looking at here. And then you could use this equation to solve problems like this. How long will it take for him to get to the legal limit? You can see where you set it equal to 0.08 and you solve. So you will see it takes 1.6 hours for him to finally get kind of to the legal limit. How long will the the alcohol leave his system? You can see it would be 6.93 hours. And again, you get that by setting your original equation equal to what your equation was. 0 is equal to that equation, 0.08, and you solve that. So for your discussion, you're going to try this similar problem for females, though. That's what you're going to do for your discussion.